Now it is important for us to differentiate between the concept of spoofing and session hijacking, which, although closely related, are different in nature. Spoofing refers to the process of an attacker finding out identity details of users and impersonating the said entity to gain access to the web application. Whereas in session hijacking, the attacker gets a token which refers to the user session, invariably a token assigned by the web application, which is independent of the identity details. As a proper example, imagine spoofing as a scenario where the attacker gets the login credentials of an user, and in session hijacking, he gets the session cookie of the user, which is valid only for one session. While we are on the subject of differentiation, it is also essential to understand the differences between a man in the middle and man in the browser attack. Man in the middle, which is MITM attack usually employs spoofing to intercept the traffic in between the client and the web application in order to find out session details. In a man in the browser, which is an MITB attack, the attackers injects JavaScript code into the client browser via the web application's vulnerabilities or redirection in order to get access to the browser-based information such as cookies, including session cookies, and use the information to conduct a session hijacking. Man in the browser attacks are harder to detect and require throughout inspection of the client browser and web application so as to mitigate damage for such an attack. Focusing on the preventive aspects of this topic, listed here are some of the countermeasures which can be employed to prevent session hijacking attacks. Encryption of the data traffics passed between the parties, in particular the sessions key, though ideally all traffic for the entire session. Second is using random generators for session keys. Thirdly, regenerating the session ID after a successful login. Fourth, changing the cookie values with each and every request. Fifth, conducting secondary checks for the users. Also, encouraging proper logout of users to dispose of the deprecated session data. The emphasis is on protection from the web application as well as the network level. Now from the network perspective, the most effective is encryption such as IPsec, which is Internet Protocol Security. It has the ability to encrypt your IP packets based on a pre-shared key or with more complex systems like a public key infrastructure, which is PKI. This will also defend against many other attack vectors such as sniffing. The attacker may be able to passively monitor your connection, but they will not be able to read any data as it is all encrypted. There might be actions an attacker could take against an IPsec enabled network, depending on if they use IKE-PSK or PKI to manage the encryption keys. But this would require an experienced hacker. Please note that IPsec is not a one-shot solution. It has its own share of flaws which can be exploited with the proper tools. Now IPsec is configured in mainly two modes, transport mode and tunnel mode. IPsec modes are associated with two core protocols, the authentication header, that is AH, and encapsulating security payload, that is ESP. Both of these protocols provide protection by adding to a datagram a header containing security information. The choice of mode does not affect the method by which each generates its header, but rather changes what specific parts of the IP datagram are protected and how the headers are arranged to accomplish this. This figure illustrates the details of transport modes of IPsec. As we can see, the encapsulation includes a header which contains the following: IP header, secondly IPsec header, the third is transport data, and the fourth is IPsec trailer. IP header deals with the routing details of the packet, while IPsec header contains the authentication header, which provides integrity authentication services to IPsec capable devices, so they can verify that messages are received intact from other devices. The main job of ESP is to provide the privacy we seek for IP datagrams by encrypting them. An encryption algorithm combines the data in the datagram with a key to transform it into an encrypted form. This is then repackaged using a special format that we will see shortly and transmitted to the destination, which decrypts it using the same algorithm. ESP also supports its own authentication scheme like that used in AH, or can be used in conjunction with AH. The tunnel mode in IPsec is different from the transport mode in the sense that it encapsulates and encrypts the IPv4 data instead of just encryption as in the transport mode. On the last slide, it is imperative to discuss about the components of the IPsec architecture. The protocols associated with it are ESP protocol, key management protocol, and AH protocol. On the bottom level, we have encryption algorithms, authentication algorithms, and domain of interpretation.